You're here because you want to master alcohols with a University of Cambridge graduate. Hi, I'm Brendan, and I'm a University of Cambridge graduate who has been teaching chemistry to many students like you over the past 9 years. I'm also the founder of the Chemistry Institution, where we have helped many students improve in a short amount of time and achieve the grades of their dreams. Be sure to check out our website in the link in the description below so that you can download a free copy of the notes for yourself and use it to run through this lecture with me today. So some common alcohols are methanol, which here we can draw is one carbon, and it's denoted by this OH group over here. Sometimes you can draw the bond between the O and the H, or sometimes if you're lazy, you can don't. I personally prefer not to draw that bond. I am just showing you the rough structure of it. So propan 1O over here will be 3 carbons long. So this is a part of the homologous series of alcohols. The chemical formula for each are as such: CH3OH. This chemical formula is CH3, CH2OH. The other last one for propan 1O is CH3, CH2, CH2OH. And thus, the general formula for these kind of compounds is CnH2n+1OH. And yes, the functional group of these alcohols is the OH hydroxyl group. Next, we're going to look at the preparation of alcohols. So a very commonly tested reaction is this reaction that you have to memorize: fermentation. This is a chemical process where microorganisms like yeast act on glucose to produce your ethanol and your carbon dioxide. Typical conditions are that it has to be in the absence of O2 to force the yeast to undergo anaerobic respiration, but that is because normal respiration will not produce your ethanol. Reagent conditions for this fermentation are rice or fruits for your glucose. Yeast as a catalyst is very important. Absence of O2 is also very important, as stated just now, and it is best at 37 degrees Celsius. So the equation for this reaction is your glucose, C6H12O6, turning into your ethanol, which is CH3CH2OH, plus your 2CO2. So do memorize this equation as well. As we have also previously covered, the hydration of alkenes is possible to produce your alcohols as well. Just a recap: you need steam, you need 300 degrees Celsius, 60 atm concentrated phosphoric acid as a catalyst. If you look at a typical reaction of ethene plus H2O, this can help you produce your ethanol. Remember, this is an addition reaction. So what's going to happen is you're going to draw the same product, and the H and the OH of the H2O are going to add across the double bond. Just like that. That is how your ethanol is produced. Another example is propene adding H2O. So we're just going to draw propene out, and we're just going to add the H2O. So everything remains the same. Your double bond turns into a single bond, and then you're going to add the H and the OH across the double bond. And this is what will get you your propan 2-ol. How can your alcohols react? Well, a typical reaction is combustion. Remember, all organic compounds go through this. This is nothing special for any functional group. So for this, refer to the alkanes chapter, where we have already discussed how your organic compounds can combust to produce CO2 and H2O. And remember, you have to balance this equation well. Your alcohols can also undergo the opposite reaction of addition, which is called elimination. An example of this is a dehydration reaction, where H2O is removed from the compound. So just imagine, elimination is really just the opposite of addition. You only need concentrated sulfuric acid as the dehydrating agent. If you have ethanol, let's say you draw your ethanol out, what's going to happen is the H2O is going to be coming out. So the OH and the H from 2 different carbons are going to come out as H2O, and you're going to form a double bond to fill the missing gap. And that really is the opposite of addition, and you're going to get back your ethene here. Alcohols can also undergo this reaction called oxidation. Oxidation, as you know, requires an oxidizing agent such as acidified potassium dichromate 6, which is K2Cr2O7, and then you can heat under reflux. If you use dichromate 6, the orange dichromate 6 will turn green upon addition to the alcohol. And how do you remember this? all you have to remember is DOG, dichromate orange to green. Next, you can also, instead of potassium dichromate 6, use potassium manganate 7, KMnO4. This is also a very strong oxidizing agent. Heating it under reflux with the organic compound will bring your purple KMnO4 to turn colorless. How do you remember this? You remember MPC, which is my pet cat, or manganate purple to colorless. Your ethanol, for example, is going to oxidize and turn into a carboxylic acid. And another reaction that is possible is the oxidation with atmospheric O2. So similarly, your ethanol is going to oxidize by oxygen in the air to form your ethanoic acid over here. Lastly, your alcohols can also undergo a reaction called esterification. This is a condensation type of reaction, and this is where your alcohols react with carboxylic acids to give esters. The reagent condition for this reaction is concentrated H2SO4 as a catalyst and heat under reflux. Here, you can actually refer to the esters chapter where we will draw out reactions and explain some examples for you. That's all for today's video. If you really learned something and you like this video, be sure to click on that like and that subscribe button so you don't miss out on free content like this. If you want to join my community of students at the Cambridge Institution, be sure to check out our link in the description below so that you can sign up for a free trial class today. Here you can learn the exact systems that we use at the Cambridge Institution to help our students improve in a short span of time and also achieve their grades of their dreams in the end.